It seems like everyone is talking about AI agents right now. They're being pitched as this next giant leap in artificial intelligence, promising to automate just about everything and act like our own personal digital interns. But what are they really? Okay, let's dive in and cut through all the hype to see how they actually work and, maybe more importantly, what major hurdles they still have to overcome.
So here's our game plan for this explainer. First, we're going to define what an AI agent actually is. Then we'll peek under the hood at their core toolkit. After that, it's time for a reality check on the timeline for this tech. We'll explore why AI learning is so brittle right now, and finally, we'll zoom out and look at what this all means for the future of intelligence itself.
All right, first up, let's get right to it. What is the big deal? What actually separates an AI agent from the chatbots we've all been playing with? Well, it really all boils down to one powerful idea: action.
So this is the official definition from LangChain, which is a super popular framework for building these things. And what's really fascinating here are the three key verbs: to reason, to decide, and to work iteratively. See, a chatbot just predicts the next word. That's its whole job. But an agent understands a goal and actually takes steps in the real or digital world to get it done.
I love this analogy from AI expert Andrej Karpathy. It just clicks, right? An agent isn't just a search engine you talk to, it's a worker. You can give it a task, give it the right tools, and it goes off and does the job. And that is a huge shift in how we should think about interacting with AI.
That all sounds incredibly powerful, but how does this AI intern actually function? How does it do anything? So let's pop the hood and look at the core components that really make an agent tick. It really boils down to three simple things. First, you've got the model. That's the large language model that acts as the agent's brain. It does all the thinking. Second, you've got the tools. These are the hands, and a tool can be anything: a Google search, a calculator, or even access to a private company database. And finally, you have the prompt, which is the super important set of instructions that tells the agent what its job is and what it's trying to accomplish. And this is where it all comes together. These parts work in a cycle called the react loop, which stands for reasoning and acting. The agent reasons about what it needs to do, then it acts by picking a tool. It then observes the result it gets back, and then it does it all over again, using that new information to figure out the very next step. It's this iterative loop that just keeps going until the job is done. Honestly, it's a lot like how you or I would tackle a big, complicated project. So, the theory sounds amazing, doesn't it? But you knew this was coming. It's time for a reality check. Because while the potential is absolutely massive, the practical side of things is still very, very new. And that brings us to a much more cautious view of the future. Karpathy really hits us with this sharp dose of reality. You know, all the hype in the industry might make you think that these fully autonomous AI employees are right around the corner. But he argues we are looking at a much, much longer timeline. So the big question is, why? What's the holdup? Well, the bottleneck comes down to what he calls cognitive deficits. In plain English, today's agents just aren't reliable enough for tricky, real-world tasks. They can't learn continuously from their experience the way a human intern would, and they really struggle the second they run into a problem that doesn't look like their training data. They just aren't robust enough yet to be let loose on their own. So let's dig a little deeper into these deficits, because the problem isn't just about making bigger models. It's about some really fundamental challenges in how AIs learn in the first place. This is such a great mental image. Karpathy's point is that reinforcement learning, or RL, which is a common way to train agents, is incredibly inefficient. Just imagine an agent performs 100 different steps to solve a math problem. At the very end, it gets one single piece of feedback, correct or incorrect. That's it. And the AI has to use that one tiny signal to figure out which of those 100 steps were good or bad. It's like trying to understand a whole book by only reading the very last word. It's just a really noisy and slow way to learn anything. And this inefficiency leads to another huge problem: model collapse. This is what happens when AIs are trained on data generated by other AIs, which happens all the time. They start to lose touch with reality. You can see here, unlike humans who can generalize and see the big picture, the models just start overfitting on their own sterile, repetitive output. They get less creative, they lose diversity, and their world of knowledge just silently shrinks, until, as Karpathy puts it, they only know about 3 jokes. So, given these massive challenges, what does the arrival of a truly capable artificial general intelligence, or AGI, actually look like? Is it going to be the sudden, world-changing explosion that so many people predict? This is the big, multi-trillion-dollar question hanging over the whole field.
The common story is that once we create an AI that can improve itself, it'll trigger this runaway intelligence explosion, leading to insane economic growth that totally reshapes society, like overnight. But there's a really compelling counterargument.
And that counterargument really comes down to this single number, 2%. Karpathy predicts that AGI won't cause some massive sudden spike in GDP growth. Instead, he thinks it'll most likely just blend right into the steady 2% annual growth the world's been on for the last couple of centuries. Just like computers and the internet and smartphones, AGI will be a profoundly transformative technology for sure, but its economic impact will probably feel more like a gradual evolution, not a sudden bang.
Okay, so let's recap the big ideas here. First, AI agents are more than just chatbots. They can reason and they can act, using a brain and hands. Second, remember we're in for a decade of agents, not the year of agents, because they still have these major cognitive deficits. Third, the way we train them now is brittle, and it leads to huge problems like model collapse. And finally, because of all that, the arrival of AGI might feel less like some dramatic explosion and a lot more like the steady, relentless progress we're already used to.
Which leaves us with a final thought to chew on. We tend to imagine the future of intelligence as this single, explosive moment that changes everything in an instant. But what if the greatest intelligence revolution of all time looks less like a firework and more like the simple, compounding interest of human and machine progress, just ticking along year after year? What if it's just business as usual?